So we'll discuss the average rate of change of a function here. Average rate of change, or ARC, let's say, is simply a relationship between two values. In a function, you have an x and a y value, and the y value changes for each x value. So the average rate of change is the y change per x change. So it's simply a ratio of how much your y changes for every so much your x changes. Okay, it's a vertical change divided by a horizontal change. And there is a very nice word that sums all of this up that you're familiar with, I'm sure. It's just slope. Okay, so these are all equivalent expressions, and also you could think of this as being vertical change as being the y difference, the value between the y's, the difference, same thing as y change, and the x change is the difference between the x's, the x difference. Okay, so all these things are exactly the same. So here we have the graph of a function with 2 points pointed out, and the instructions tell us to determine the average rate of change between the points. So the average rate of change is the slope between these 2 points. In other words, it's the slope of this line segment. Okay, and so all that matters here is that you can tell here your y's are decreasing, 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 increasing, decreasing, and you get here. Whenever you look at the average rate of change, we don't care about all the stuff in between. We just care about the average of all the things in between. And when you look at that, you get this simple straight line. So if we want to determine the average rate of change, we need to determine the slope of this line. So we need to know the difference between the vertical distances here and the difference between the horizontal distances. So the average rate of change would be the vertical distance, which is negative, let's see here, we're down here, so negative 1, 2, 3, 4. So the vertical distance is negative 4. The horizontal distance is positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's negative 4/12, which reduces to negative 1/3. Every time I have a vertical distance of negative 1, meaning drop 1, I go horizontally to the right 3. That's the interpretation of this. And so that's the average rate of change between these 2 points on this function. Now, between different points, it would be different, right? Because your points could have a positive slope between them, a zero slope between them, etc. Now, you don't have to be given a graph to determine the average rate of change. You could be given a function, which represents a graph, and given the 2 x values that you would use. So if you want to determine the average rate of change in this particular case, you would have to know the vertical distance between these 2 points and the horizontal distance. Well, the horizontal distance is easy. It's 5 minus 2, right? Because those are both x values. They're separated by 3. The vertical distance is harder, though, because we don't have y values. But luckily, a function tells us how to calculate y values. So if x is 2, the y is going to be 2 squared for this particular function. And if x is 5, y is going to be 5 squared for this function. So the difference between those would be 25 minus 4. Now notice when I subtracted, I used this x first, and I used this y first, right? So you can do it, you can choose whichever pair you want to use first. Just make sure you're consistent. Make sure if you use this x first, you use this y first, etc. If you use the other ones first, you'll get the same value in the end, but you have to be consistent. So this reduces to 21 over 3, or 7. The average rate of change is 7. Sometimes you're not given any numbers at all, but you set it up the same way. Get your 2 y's using your function, which I've done here, and then apply slope. So here I'm taking the difference between the y's, and I'll divide it by the difference between the x's. And I'd recommend using parentheses here. Now simplify this using what you know about complex fractions.